Welcome to today's daily video lesson. Today's topic is line graphs. As with all daily video lessons, feel free to pause the video and attempt the question on your own before seeing the solution. Here we have a graph. It's a line graph, as expected, and we are interested in the total distance traveled from t equals 1 to t equals 4. In this case, we just need to simply interpret the data. T equals 1 is right here, and t equals 4 is right here. Notice that this is the spot where it is flat. It's a constant speed. That constant speed is 0.5. Don't forget your DIRT formula, that distance equals a rate times time. Since we're interested in distance, we can plug in the rate, which we determined to be 0.5, with the total amount of time elapsed. Don't confuse this with the number 4. It's actually the distance between time 1 and 4, so 4 minus 1, which will be 3. 3 times half is 3 halves, or simply 1.5. Sometimes the option choices are going to be line graphs themselves. In this case, simply read the information that is given to you carefully and eliminate wrong answers as you go. Notice that we start uniformly with 30 in all 4 option choices. The first change is when Tuesday comes, in which 10 tons are shipped and there's no deliveries. Shipping the gravel out of the store, or the stock, is going to be subtraction. Therefore, we do not gain. Instead, we decrease. Now, both options C and D say the same thing with regards to Wednesday. We will be at 40 tons on Wednesday. The difference comes in what happens between Wednesday and Thursday. It says that on Thursday, the company made no shipments and received no deliveries. That means between Wednesday and Thursday, nothing happens. Thus, the option is D. There are questions that involve a stem, and based off of that stem, sometimes there are either 2 or 3 questions with the same information. Here is the stem on the left, where the question is right here. There's information given about this particular line graph. Assuming good growing conditions, how many years old is a giant sequoia tree with a trunk diameter of 19 feet? Notice it gives the y-axis measurement. The units of the y-axis are in inches, and we have feet, so we first convert that. 19 feet converted to inches. We multiply by the unit conversion 12 inches over 1 foot, cancel the feet, and multiply 19 times 12, which is 228. Notice that the graph only goes up to 200, but 228 is pretty close, somewhere about here. Notice that the line is going to only go up to about there. When looking at the option choices, we know that the age of the tree has to be greater than 90, so we can eliminate A and B. We can also eliminate D, because D doesn't make sense. 494 is almost 500. That X value, if you were to scale out this line graph, would appear somewhere way over here, whereas the value we're expecting is somewhere close, a little over 90. Sometimes you will need to use common sense and good approximation reasoning skills in these questions. Here, the linear model Z equals 4/3 W is used to find the height. We want to know what W represents. This is where we return to the stem and observe that a giant sequoia tree grows 4 feet vertically every 3 years. Notice that that is the description of that slope. 4 feet vertically, rise, over, run, 3 years. Therefore, this variable W is describing time or age. It is not simply the number. The height is Z, so we can eliminate B. And options C and D are just numerical quantities that are fixed. W is the age, and multiplying that age by the slope, that is, the rate of growth, will give you height. Here, we observe another interval. We want to see when the water usage is above 750 gallons per week. 750 is given right here, and to be above 750, we need these data points. Identify the week intervals that this falls in. Although it's not exact, we see that it will be something greater than week 20 and something less than week 28.